Hello, greetings to one and all who are watching this video. My name is Satish K. Ravichandran and I am going to present a video on the topic of visualization of various sorting algorithms. I have completed my implementation of sorting algorithm using Java in my first project assignment, which I will be uploading in my Git soon. My implementation works with generic types and hence it sorts any input data like integer, string, float, etc. And the datasets I have used for analysis of various algorithms are compliant details available with the US government. It can be used to sort the data and find out the recent complaints, real complaints, which are fake, and so many things like that. My second dataset will be temperature info for different stations in US available with data.gov. So even this can be used in various methods. Now, in this project, I have used D3JS for implementing visualization of various sorting algorithm with animation. Random data sets and reverse data sets are the two data sets which I have used to show the various sorting algorithms with animation in this project. Now I am going to show the animation for bubble sort. Every element is compared with its neighbor element. Two elements are sorted if the order is reversed. In an iteration, if no more swaps are needed, then the list is considered as sorted. In this animation, we can also see the swapping of elements. I have also listed the comparisons and swap operations happening in the web page. Insertion sort works by taking each element and inserting in the array in sorted order. So the sorted list will be in order at the end of the insertion of all elements. Here we can see that every element is taken and inserted into the front of the array. We can also see labels showing the operations taken at each step. Selection sort works by dividing the list into sorted and unsorted part. Initially, the sorted part is empty. Selection sort works by finding the minimum element from the unsorted list and adding it to the sorted list. Once the unsorted list is empty, the sorted list contains all the elements in sorted order. Here in this video, we can also see the minimum element at every step and finally the list is sorted. Merge sort. Merge sort method works by divide and conquer method. Merge sort divides the list into two parts at every step by finding the middle element. When the list contains only one element, the list is sorted. It merges two sorted lists based on the values to sorted order. Here in this video, we can see that a sublist is sorted and merged at every iteration. Quicksort works by choosing a pivot element at every step. All the elements lesser than the pivot element are placed left of the pivot element. All the elements greater than the pivot element are placed right of the pivot element. When this is followed for every sublist, the list is sorted after few recursive calls. Here in this animation, we can also see the pivot element selected and the sublist sort at every step. Now, I am going to compare the performances of these 5 sorting algorithms against different metrics. I took data sets provided by US government in the website called data.gov and applied these 5 sorting algorithms. All my implementations are linked list based, hence they are effective in terms of memory usage for dynamic datasets. I computed degree of sortedness metrics by finding count of inversions. Here we compare the data size against runtime for various algorithms. For every data size, the algorithm is executed for 5 times and average runtime is considered. As average metric values are considered, it takes care of outliers. Here we could see that bubble sort takes more computation time compared to other algorithms. It is completely a brute force like approach, as every element is compared with every other element at each iteration. Selection sort performs better than the bubble sort as minimum element is added to the sorted list at every iteration. When we consider longer databases, quicksort and merge sort are best algorithms to consider. In the second sort, degree of sortedness is calculated by finding the count of inversions. It is compared against runtime and we could see that bubble sort performs the worst of all the algorithms considered. Quicksort and merge sort works best as it is the divide and conquer method, makes it easy to sort the complex databases. Here, in the third chart, I compare the data size of the datasets with memory used by the algorithm. Memory usage metrics will be very critical in applications like mobile, where memory is always limited. Memory usage is hence one of the important metric to be considered. Here, insertion sort works best as the elements from list are inserted to front of the list in sorted order. It involves swapping of locations for linked list nodes. Hence, works the best in terms of memory usage. Quicksort and merge sort performs better than bubble sort, but it is not as good as insertion sort in terms of memory usage, as quicksort and merge sort involve in recursion. It occupies more spaces in the stack. In the fourth chart, degree of sortedness by number of inversion is compared against memory usage. Here, insertion sort works the best in terms of memory usage. As no additional space is needed, only elements are added to the front of the list in sorted order. Quicksort and merge sort needs more space for bookkeeping information in stack. So they are performing as best as insertion sort. Bubble sort works the worst optimal way in terms of memory usage.